this video, we are going to explore what is meant by monostatic and bistatic radar. So from this picture itself, you may get some idea about what it is. Okay, so let's see what is meant by monostatic and bistatic radar. So let's start with some analogies because analogies will always help us to have a quick hang of the topic. So consider a mirror and we are having a torchlight and the light coming from the torchlight is hitting on the mirror at 90 degree. So in this case, we know that the light will be reflecting back at 180 degree and we can see that light reflection. So here, this is our source, and whenever hit on the mirror and when it is reflecting back, it is always coming back to the source. So next, consider if that mirror is tilted 45 degree and light is incidenting on it. So in this case, that light will not be coming in the same path as that of the transmission. So it will be reflected in a different path. Here you can see that this is the incident ray and this is the reflected ray. That means that the light will not be seeing when we are observing from this portion. That means that this is the source portion and this is the receiver portion. So these two analogies actually represents the monostatic and bistatic cases. So here our source and the receiver positions are the same. That means it corresponds to a monostatic case. That is, we have only one source and one receiver. The same thing is acting as the source and the receiver. That is monostatic. And in case of this case, we can see that the source and the receiver are different. That is, it is like a bistatic radar. It has two things. One is acting as a source and one is acting as the receiver. That is the meaning of bistatic. So let's see what is meant by monostatic radar. So in this monostatic radar case, the transmitting and the receiving antenna positions will be the same. That means the same antenna will be working as the both transmitter and the receiver. So this antenna will be transmitting the wave and when it hit on the target, some waves will be getting reflected and these reflected wave will be received by this same antenna and it will be processing to get an information about these targets range, velocity and direction. So let's see how it is. So when we have a radar here, it will transmit electromagnetic wave and when it hits on the target, based on the target size, shape, geometry, it will be reflecting and scattering the waves. So some part of the waves will be getting absorbed based on the material properties of these structures and some part will be getting reflected and some part will be getting scattered. So the part of the waves which is getting reflected will be received by the same antenna and that will be processed to get information about the range, velocity and the direction of this target. So that is how the monostatic radar is working. So this is the basic block diagram of the monostatic radar. So it will be having the same antenna which can be connected to the transmitter block and the receiver block. Here we have a duplexer. So it will be acting as a switch. That means it will be getting connected to the transmitter and receiver based on the mode. So this antenna will be transmitting the electromagnetic wave and when it hit on the target, some part will be getting reflected back and this reflected signal will be received by the antenna and it will be given to that receiver session and it will be processing that result to get the information about the target. So that is the monostatic radar. That means it has only one antenna to act as the transmitter and the receiver. That is the name monostatic. Next is bistatic radar. So in case of bistatic radar, from the name itself, it suggests that it has two antennas, one transmitting antenna and one receiving antennas which are placed at different locations. So the wave coming from the transmitting antenna will be hitting on the targets and it will be getting scattered back and it will be received by this receiver antenna. So let's see why we have to place this receiving antenna in this position, why it is not suitable to use the same antenna for the transmission and reception as that of the monostatic radar. So let's see what is the importance of placing this antenna at these positions which is separated from the transmitting antenna. So consider the case of the scattering from the target. So here we can see that based on the geometry, size, shape of the targets, the waves will be scattered and reflected in different directions. So the waves getting reflected back is actually received by the monostatic radar, and we will be getting the information about these targets. So this is the case of the monostatic radar. So this gives rise to the idea to the military officials that if we can avoid these reflections, we can make sure that this target is invisible to the radar, right? That means that if we can avoid these reflections, like if we make some modifications on the shape of the object, material of the object, we can avoid these reflections from the target. So if we can avoid these reflections, it will be only scattered in different directions. So this radar will not be able to see our target, right? So that was the concept of stealth technology. So in stealth technology, it was like uh, the modifications were done on the size, shape, and material of the object so that it made sure that there is no reflection back to the radar. So in this case, we can see that there is no reflection back to the radar. So this radar will not be able to detect this aircraft. So this aircraft can easily attack this country because our radar is unable to detect our enemy aircraft, and this aircraft can easily enter into the zone and make the attacks. So this give rise to the idea of the bistatic radar. So here we can see that some of the waves are getting scattered in different directions. So what will happen if we are placing some receiving antennas at these positions? It can definitely receive these scattered signals, right? So this will give an indication about the target. That is the idea behind the bistatic radar. So bistatic radar can detect even the stealth aircraft because we are placing the transmitting antenna and the receiving antennas at the different positions. So in case of the stealth technologies, most of the concentration will be to avoid the back reflections, but there will be some scattering. So if you use the bistatic radar, we can always detect the scattering. But if you want to completely avoid these scattering also, it is like a complex technology because we have to have complex geometry so that it will avoid any type of scattering. So in common cases, there will be some sort of scattering, and based on the bistatic radar positions, we will be able to get detect this even the stealth aircrafts. So that is the idea of the bistatic radar. In case of bistatic radar, we have the transmitter antenna and the receiver antenna. They are positions at different directions, and the wave from the transmitting antenna will be hitting on the target, and the receiving antenna will be receiving, and it will be processing that. So this is the basic building block. Here you can see that we have two antennas, and the transmission from the transmitting antenna and the reception by the receiving antenna. So in order to calculate the range of this target, it is very important to know when this transmitting antenna started the transmission, because the total range depends upon the time taken for the wave to travel from this transmitting antenna and to receive at the receiving antenna. So the total round trip time is taken to calculate the range. So this receiver has to know when it started transmitting. That means that there must be some sort of synchronization between these transmitting and receiving antennas. So usually it is provided by GPS signals, or we can see that when this transmitting antenna started transmitting, some sort of direct signal communication in between this transmitting and receiving antenna will happen. So this direct signal can also be used as the reference for the synchronization. So that is how the synchronization is happening in case of the bistatic radar. So let's see one of the important factor known as the bistatic angle. So this is the angle subtended between the transmitter, target and the receiver in the bistatic radar configuration. So this angle is known as the bistatic angle. So when this angle is zero, that means that both the transmitter and the receiver are the same position. That means we are using the same antenna for the transmission and reception. We can call it as the monostatic radar. So when it is 180 degree, that means the transmitting antenna will be here and the receiving antenna will be here. So it will form a straight line, and it is known as the forward scatter radar. For all other angles, we can say this is a bistatic radar. So that is the importance of this parameter known as the bistatic angle. This is just for defining how the configuration of these antenna is. So let's compare monostatic and bistatic radar. So first one is TXRX position. In monostatic case, we know that both transmitter and receiver are at the same position. In bistatic radar, they are at different positions. So when we consider the system complexity, in case of monostatic radar, it is simple. In case of bistatic radar, it is complex because it requires some sort of synchronization. And in case of monostatic radar, it don't require much synchronization because we are using the same antenna both for transmission and reception. So it is very easy. But in case of bistatic radar, it's very hard because we have to use other GPS signal or direct communication signal processing is used to make the reference. And in this case, the stealth detection we can say weak, because if our the target is based on the stealth technologies, there won't be any waves coming back to the radar. So the stealth detection is weak in this case. But in this case, the stealth detection is strong because the scattered signals can be received by this bistatic radar. And next is low probability of intercept. This means that so the low probability of intercept means that the probability of intercept actually means if we have some technologies inside this target, and if some wave from the radar is hitting on the target, so this target can get an indication about where our radar is located, right? That is the probability of intercept. That means that this target can get an indication about the position of this radar. So it is always important to have low probability of intercept. That means that our radar should be invisible to the target also. So in case of the monostatic case, when the wave from this radar is hitting on the target, this target can definitely get an indication about where our radar is. So here the probability of intercept is very low because this target can get an indication about where this radar is. But in this case, when this target receives some signal from this radar, it will not get any indication about where our receiver radar is. That means that it does not have any idea where our receiver radar is. So in that case, by static case, the low probability of intercept is very high as it does not have any idea about where our receiver is. In case of monostatic radar, the cost is high because we are using the same antenna, so we have to use some duplexer, that means some switching devices to switch between the transmitter section and the reception section. So in that case, the cost is very high, and in case of bistatic, the lower. And in case of the monostatic, counter jam ability is medium. That means that this uh, target already has an indication about where our receiver is, so it can cause some jamming to our radar. But in case of the bistatic radar, as receiver is in different positions, it is not possible to easily jam our radars. In case of the installation for monostatic radar, it is on the single site and it is on the multi-site. And monostatic radar is mainly used for air traffic control, weather radar, and automotive radar. And bistatic radar is mainly used for the military, border applications, and the stealth detections. So that's all. I hope you get some idea about what is meant by monostatic radar and bistatic radar and what is the importance of bistatic radar in stealth applications. Thank you for listening. And if you find any of our videos useful, kindly support by liking, sharing, commenting, and subscribing. Thank you.